Hello, everyone, and welcome to the webinar, Tackling Infiltration and Inflow with SLiiCER. This is part one of a multi-part webinar series for ADS. Today, we'll focus on the big picture view of I&I. My name is Eric Lott. I'm the marketing manager here at ADS, and I'll be serving as your host today. Today's presenter is Kevin Enfinger. Kevin is a senior product and region engineer here at ADS Environmental Services with 30 years of experience in environmental engineering and consulting. Kevin holds a Bachelor of Science in Chemical Engineering from the University of Florida and is a registered professional engineer. He is a member of the American Society of Civil Engineers and the Water Environment Federation. So thanks, Kevin, for all you do for our company, all you do for this great industry we're a part of, and all the time and effort you put into preparing this webinar for us today. So without any further introductions, Kevin, I will turn it over to you.
All right, thank you very much, Eric. And to the attendees that are out there, welcome. It's a pleasure to have you here with us today for this webinar. If you've been a part of our webinar series in the past few years, I know during the pandemic we had quite a few webinars that were going. We took a small break. And this is the first webinar we have back. So it's good to be back in the webinar game. We enjoy this. We enjoy sharing with those in our industry. So today we're going to talk about I&I, and we're going to talk about it in the context of a software product of ours called SLiiCER. So let's get started. So I know that anyone out there that works with collection systems, whether you work directly for a municipality or a utility, or you're working with a consulting engineering firm, I&I is a problem that we often see. In fact, when we talk to our customer base and ask them what's the number one problem you're dealing with, I&I is always up there right at the top. So if you're having a problem with I&I in your system, you're certainly not alone. Most wastewater collection systems do. And getting an understanding of that often starts with flow monitoring and rainfall monitoring, and understanding that relationship between rainfall occurring over your system and how much of it actually gets in your system and where. And of course, our big challenge as an industry in water and wastewater in general is to keep that water out of our sanitary sewers. So the purpose of this particular webinar series is to learn how to apply SLiiCER, which is our cloud-based I&I analytics tool, to prioritize I&I and to help get that I&I out of your collection system. Now, this is a big topic, and so we're going to focus on it in bites and pieces. So part one that we're here to discuss today is what I call the big picture. We're going to talk about a kind of an overview of I&I and an overview of how SLiiCER fits into that picture. And then in some additional parts in some future webinars, we're going to dive in deeper and get a little further deeper into the features of SLiiCER and how to use it to understand dry weather flows and to understand wet weather flows in your system. And I suspect there's going to be a few extra webinars that come along after that where we talk some additional detail on certain features. So I want to start out everybody with a baseline. I know I was looking over the webinar registrant list, and there is quite a range of people that have registered for this webinar. Some I can tell are probably new to the industry, maybe early career professionals, and there are some other very seasoned folks that are attending this webinar. So we have some experts in our field as well. So with that in mind, I want to bring everybody along at the same pace. And so you'll find that we're going to discuss things today at kind of a fundamental level to make sure that everybody's on board. So when I talk about SLiiCER, it is an analytics tool that we have available at ADS. Some of you may have used it in the past. It's actually been around for quite some time in previous forms and iterations. And what we have done is we have now moved that functionality into our cloud-based web system. So SLiiCER basically allows us to see and understand and act on I&I in your sewer system via flow monitor and rainfall monitor data. So if you have worked with us in the past, or we have worked with you on projects using our flow monitoring equipment or providing flow monitoring data to you, you have probably accessed that information through a cloud-based platform called Prism. And if you have, most of you are familiar with that platform as a place where flow monitor and level monitor and other data comes into the cloud and is then accessible to you through Prism via the web. You might use Prism to view that data, some simple data views. You might use it for some alarming, or you might be exporting the data out of that system or grabbing it with an API or some other means. But for many people, it's at its basic element, or its basic essence, if you will, it's a data platform. And most of us think in that context. But it also provides additional insight beyond that. So having just data is only part of the path forward when we're trying to understand how our collection systems are performing. We also need some insight into what that data means. And from an infiltration and inflow standpoint, SLiiCER is the piece that does that for us. So in this particular webinar today, I'm really going to focus on three key areas. So I'm going to talk about some terminology related to I&I and I&I studies. I'm going to talk about methodology, and this is being more at a conceptual level about how we go from flow monitor and rainfall data to I&I insights. And then the tools at the bottom. SLiiCER is the tool that we're going to discuss today that puts this terminology and methodology into motion. So for some of our newer people to the industry, I wanted to make sure we had some clarity on terms. So we're going to start out with some of the basic terms that we're dealing with, the first of which is infiltration. And what is infiltration? So infiltration is water that enters a sanitary sewer system, and it comes in through the ground through defects in the sewer system. So it can be primarily dependent on groundwater elevations, but it may also be influenced by storm events and even leaking water mains. So the main point with infiltration is it's extra water that gets in the sewer system. It's not supposed to be there, and it gets in through defects in our system. The next basic term we have is inflow, and that is stormwater runoff that enters a sanitary sewer system from direct connections. So it doesn't travel through the ground to get to the sewer, but instead it comes through things like building downspouts, cleanouts with a missing cleanout cap, foundation drains, sump pumps, basement and area drains, or cross connections with storm sewer systems. We often think of inflow as that extra water that gets in very quickly, and that infiltration gets in a little bit more slowly because it has to travel through the ground and find a defect to enter. When we put those two together, infiltration plus inflow, and we get infiltration and inflow, or as we like to abbreviate in our industry, we simply call it I&I. And you'll see it represented usually at I/I or an I and I. I typically use the one on the lower left myself, but all of these are synonymous, and they all mean that combination of both infiltration coming in through the ground and the direct inflow sources that impact our system. And of course, the impacts of these can be significant. So we think inflow is primarily that component that really eats away at capacity, especially during wet weather, contributes to wet weather overflows. But we also think of infiltration in terms of something that's consuming capacity and basically every day in our system. So I find that when I work with coastal area communities, they are typically more laser focused on infiltration than some of the other communities more inland. because they're often flatter. They're having to pump flows multiple times before they get to the wastewater treatment plant, and it's a significant cost day in and day out. So infiltration and inflow, I&I. Now there's another way to parse the collection of I&I into pieces, one of which I'm going to talk about today is base infiltration. Some people use the term groundwater infiltration for this as well. And this is primarily infiltration that comes into our system during dry weather conditions. So it's not specifically associated with a specific wet weather event, but it's infiltration that's coming in as a result of groundwater levels, soil moisture levels, or even leaking water mains. But the key here is that it's coming in dry weather, not with specific wet weather events. And the other term I want to clarify is what we call rainfall dependent infiltration and inflow, or RDII. The other term I see people use is rainfall derived infiltration and inflow. They're one and the same thing. And this is the combination of infiltration and inflow that enters a sewer system as a direct result of rainfall. So you have that rainfall event, you see the spike in flow go up in your system, and then you see it trail off and recover back to normal. So that collection is called RDII. So with some of that terminology out of the way, let's look conceptually at what we're doing with the I&I evaluation process. So I have a graph here in front of you, and it has two data streams on that graph. The one at the top here is rainfall. So that time series of rainfall, we call it a hyetograph. And below at the bottom, we have a time series plot of flow rate data from a specific location in the sewer system. And we refer to this plot as a hydrograph. And the first insight that you visually get from this graphic is that when it rains, we see a corresponding effect or impact in the sewer system. We see those extra spikes. So just about every time it rains, we see a big increase in flow. So we'd like to learn more about this process, and this is the process that we use in SLiiCER conceptually. So the first thing we need to do is we want to get a handle on rainfall events that have occurred. And not just every rainfall event, but the ones that are most significant to us. So if you look in most data systems or most data exports of rainfall data, you'll find that it's very easy to roll up the statistics on that rainfall by daily totals. In fact, that's the way most of us probably look at rainfall data, is in some type of daily total format. And when it comes to I&I evaluations, the daily totals may not be exactly what we need. What we need to know is when it started raining, and we need to start the clock, or start the counter, if you will, at 0 when that event started, and get a total on the rain event. So rain events don't always fall neatly within one calendar day. Sometimes they straddle 2 different days. Sometimes they run longer, but we would like to know when these events started. We'd like to know the statistics associated with them, and we would like to not have to do that manually. So SLiiCER does that work for you. We have some criteria that can be configured for selecting what a significant rainfall event is. SLiiCER will find those events for you, automatically identify them, and develop the statistics associated with them. So that's the first thing. Now, before we can get around to evaluating the wet weather impacts of this rainfall, we have to understand what the baseline condition is in that system. So this is where we evaluate dry weather. So in this top hydrograph here, you'll notice that just conceptually, I've highlighted a number of days in green. And those days, instead of plotting them end to end like you see on that top hydrograph, we're going to go to this bottom left hydrograph where I plotted them on top of each other, midnight to midnight, and we develop a dry day diurnal pattern for this particular location. This gives us a baseline of what's happening in this sewer when it's not raining. Now you'll notice there's two patterns shown. One's in light green, one's in light blue. And that represents the weekday and the weekend diurnal pattern. We analyze these separately because the patterns are different enough that if you're evaluating I&I that occurs during the storm event on the weekday, it can be different than the calculation you're going to do on a weekend when that baseline flow pattern is different. So we evaluate those two by default, and we can do other day combinations as well. The next thing we're going to do is we can actually split this dry day flow up into estimates of wastewater production and base infiltration. So that red line on the bottom left graph represents an estimate of base infiltration that is a part of this dry day diurnal curve. So in addition to the statistics like the min, the average, and the maximum dry day flows for your different day groups, we can also give you an estimate or a split of these flows into wastewater production and base infiltration. So once we have that, we can now evaluate each of these individual rainfall events. I think I've got 8 rainfall events shown here and their corresponding response in the sewer system. That third event, the one right in the middle, is the one I have highlighted at the bottom. And conceptually, all we're doing is we're taking the actual flow during that rainfall event and we're comparing it to the dry day diurnal pattern that we've established for this site. And the difference between the two, that shaded gray area, is the RDII volume. And we can also, of course, calculate the peak RDII that we see during the event. And we can do this for all 8 of these rainfall events as well. We do the same exact same. Now, there's some additional things that are going on in the calculation process to make some adjustments for any deviations between the dry day curves and the actual data before the event. We're going to cover that on the webinar 2 and 3. So we're not going to get into that detail today, but know that that's happening in the background. Now, once we establish what the I&I looks like for each individual storm event, we like to take a look at the consistency of that response. So this graphic here on the bottom represents the I&I calculated for each event compared to the amount of rainfall that fell. And there's a few different graphs like this that we can produce and take a look at. This is one of them, but it gives us an idea of the consistency of the response that we see in the system. And we should see a trend that looks about like this. But the idea here is the harder it rains, the more I&I you expect to see in your system, and you can use that to quantify. So everything I've shown you to this point is dealing with one flow monitor location and its associated basin. At the end of the day, we want to compare what's happening in one place in our collection system to what's happening in other places. So I want to prioritize the I&I. And I think all of us are well aware that there's probably enough I&I in every sewer system that we look at that it's impossible for us to get around to all of it. And there's probably not enough money or funding for us to deal with it all at once. So we're always in a position where we need to prioritize. And so in this example, this basin we're looking at was prioritized number 2. It's not the worst, but it's right up there. So we want to always take our resources and put them where we can have the biggest impact. And this is one way to ensure that we're putting those resources in the right place. So just conceptually, some of the things we're doing is we're taking the flow monitor and rainfall data. That's allowing us to split that data into dry weather pieces and wet weather pieces. And the dry weather data, we're going to zero in on some simple statistics like minimum, average, maximum dry day flows, and also splitting that wastewater, that dry weather flow up into wastewater production and groundwater or base infiltration. With the wet weather portion, we can characterize those rainfall events. How much rain fell, what's the return frequency of that rainfall event, statistics like that, and then calculate the RDII parameters associated with those events, and be able to see the trend amongst the various rainfall events and prioritize those events or that performance amongst our different basins. Now I've got a couple of other terminology pieces, and then I'm going to switch over to a live demonstration of the SLiiCER application. So I find that some people, when they first start getting involved in I&I studies, you have to make sure that there's a distinction in your mind between a flow monitor and a flow monitor basin. So a flow monitor is just located in a specific pipe. It's measuring flows that come from down that pipe. And so you get a flow rate, you get a depth, you get a velocity. And so it's measuring what's happening there. But it's also indicative of what's coming from a certain area upstream. So I have a definition here of a flow monitor basin. And it's basically just a series of interconnected sewers within a sanitary sewer system that collects and conveys wastewater to a given flow monitor. So the size and the geographic extent of these are going to be system specific or project specific. But these basins have useful characteristics for helping us look at I&I. So we see a flow monitor basin has an associated land area. It has a length of sewer contained within that basin. And there's even other characteristics that can be insightful to us, including what's the land use of that basin, what's the population or the house count inside that basin, or even what's the sewer material or the sewer age. So these are all useful characteristics that go along with the flow monitor data. I can tell you this, as a company that provides a lot of flow monitoring services, we provide the flow monitoring data and the rainfall data, but this other information about the basin, this comes from your local GIS information, so your geographic information system. So often, if we're working on a project, I will be asking our customer or our partner for this information, and we will be leveraging it inside SLiiCER. Other similar terms to basin that you may hear that are used, you'll hear sewer shed, sub-basin, a monitor basin, meter basin. They all have the same meaning in this context, but those are some other terms that you'll hear. So when we talk about applying this concept to an I&I study, there's a very simple example I have here on the far right. You'll see the green dot represents a flow monitor. I'll call it FM1, and it is measuring flow coming out of a basin, which I'll call flow monitor basin 1. You'll also notice we have a few rain gauges that happen to be in the area, and we can also apply this rain gauge data to estimate what rainfall fell on top of this basin. Here's what a basin looks like in real life. So the white arrow on the far left, if we are monitoring what's coming in from the east here, we get a basin that looks like this. And you can see very easily we've defined a certain land area. Within that area, there is a fixed number of sewer pipes with a certain length to them. You can see the individual homes that are in this residential area, so we can get a good idea of what the house count is. Perhaps even grab the water usage data if we wanted to. But these are the kinds of parameters that we're interested in when we talk about a flow monitor basin. Two other terms I want to make sure you're aware of in the context of SLiiCER. You'll hear us throw around two terms quite a bit. One's called gross and one's called net. When I talk about gross flow or gross basin filtration or gross RDII, I'm talking about the total flow that's coming through the monitor. So again, this monitor, the green one on the far right, FM1, the gross flow for it includes this entire red boundary that you see. And that's because FM2, flow monitor 2, the blue one, is upstream, and its flow flows through basin 1 and also passes through flow monitor 1. So the first thing that we're looking at in SLiiCER is going to be gross flows. And then we can look at flow monitor 2, and we can actually subtract that information out to help us evaluate and understand what's happening in flow monitor basin 1. So if you hear us talk about gross flow and net flow, or gross I&I, net I&I, in the context of SLiiCER, this is the concept that we mean. Last term I'm going to give you here is actually a study. Now, we think of many times a study as a report that somebody hands us. In the terms of SLiiCER, a study is any group of flow monitors or rainfall monitors that we evaluate together for a specified calendar period. So a certain start date to a certain end date, we call that a study. And in SLiiCER, we can manage 0 to many studies, and we'll take a look at that in a minute. So with that, I want to get into the application itself. So if you're in Prism, you've probably recognized this screen. So this is the home screen inside Prism. You'll notice that there is a black toolbar at the top, and one of the options is Analytics. Now, SLiiCER will appear under that. It is an additional permissioned feature within SLiiCER, and if it's accessible to you, you can select it. And I'm actually going to go out to our live system. This is our production system, and we'll take a demo here of SLiiCER. So I'm under the customer SLiiCER demo here. You'll see on the map there are a few flow monitors and a few rain gauges. Just to use here as an example, I'm going to come to the Analytics tab and go to SLiiCER. That brings me to the SLiiCER dashboard. This allows me to manage different studies that I have for this customer. And you can see for this webinar, I have a demonstration study 1, 2, and 3 sitting out here. And to access any of these, I just click on the particular study, and I'm inside that study. So once you're inside a study, it really works left or right on this gray toolbar. You'll notice I have a configuration page, settings, basins, rainfall, flow, and results. And today what I'm going to do, keeping big picture in mind, I'm going to walk through all of these particular tabs. We're going to take a look at them in general, and you'll recognize the process or the concept of I&I evaluation that I showed on some of the previous graphics. You'll see them at work in SLiiCER here. So the configuration is really just a summary of what the study is that we're looking at. There's a study name, there's a description. It'll tell me a location group of monitors that I'm using. In this case, it's 3 flow monitors and 3 rainfall monitors. If I want to see the exact list of those, I can click the details and see a list. It tells me the start and end date of the study and calculates the study duration for me. In this case, it's 121 days. And it tells me the step length that we're using for the study. The step length is 1 hour here, and step length is just another term for averaging interval. So we're going to use hourly average data for the purpose of this study. Now, you'll also notice there is a hyperlink here for me to refresh study data. So what we do when we create a study is we actually go to the data bank, if you will, in Prism, and we grab a copy of the data that we're interested in using. And you ask me, why do we grab a copy? Sometimes, particularly early in the stages of a project, data is being gathered. We may have some additional adjustments that get made to that data over time, over the course of the project, as we gather additional supporting information from the field. And so that data may adjust up or down. It may change. Anytime we create a study, though, we want the creator of that study to know what data they're using with. So it's always going to have the data that was in place at the time that you created the study. And that data is not going to change from underneath you unless you go and refresh it. So as an engineer, when I get to that evaluation stage, or even just a sandbox phase where I'm wanting to look at some data, I don't want that data really changing out from under me without me knowing that it's happening. So that's a protection tool, if you will, for the SLiiCER user, and keeps that engineer's perspective in mind. So the next tab on here is settings. And we're not going to get into a lot of detail in the settings, but the, the takeaway I want you to have from our discussion of settings today is that these are settings that help SLiiCER's default algorithms work, but they are also configurable settings. So I think what I find when people get inside SLiiCER, the first few times they will play around with SLiiCER with all of its default settings intact. And then over time, maybe after a project or two, you will find the settings that kind of work best for you. In some cases, that's the analysis you want to be done in a particular way. So you'll tweak some settings to help you achieve that. In other cases, we find that customers in different parts of the world have different climates. And so you'll want to adjust some of these default settings to your climate so they give you the best results right off the bat. So just let me walk through some of the types of settings we have available to configure. The first one here on this sub-tab is dry day. So these are all the parameters we have to allow us to basically tell SLiiCER what we think a dry day is. And so it will go through automatically and take a cut at what it thinks dry days are based on these parameters. Likewise, we have several base infiltration methods that we can choose from. This one's currently set to one we call the Stevens-Schutzbach method, but we also have two others. We have a percent minimum method, a wastewater production method, and we've actually got another one being added before the end of the year. So depending on which of these methods you prefer, you can select that method and use that one for a given study. I mentioned earlier that by default, we look at dry day patterns and derive dry day patterns in terms of weekdays and weekends, and you'll see that configured here by default. We can have as few as one day of the week group, meaning we lump everything into one, or we can have as many as 7, where we do a separate day of the week group for every day of the week. I find that this particular setting here, the default setting, will take care of probably 98% of the work you'll ever do, and this works very well. I have had specific cases on specific projects where I've had to adjust this to something else. And probably the most unique example I share with people is I did an I&I study a number of years ago at a religious-based university in Florida. And as part of that, this campus had activities that not only revolved around the academic week, but also their religious services on campus. So I had to have a separate day group for weekdays, which was Monday, Tuesday, Thursday, and Friday. I had a separate day group for Wednesdays because they had some Wednesday evening services that had pronounced differences in flows from the other weekdays. And I also treated Saturdays and Sundays separately because they had worship services on Sundays that made the Sunday pattern distinctly different from Saturday. So that's an example, one example that I ran across where I had to use this feature. It's not used all the time, but it's nice to have when you need it. The next setting we have is a storm event setting. So we have a minimum rainfall threshold and also a minimum time between rainfall events. So depending on how you set this setting, the time series rainfall will be split up in different ways into different rainfall events. Sometimes it's a subtle difference. Sometimes it can be more significant, particularly if you have rainfall events that are grouped very closely together. But this setting helps you and helps SLiiCER understand what you think is significant, and it will pull out those events for you. We have a few other settings I'm going to get into in more detail in a future webinar, but I do want to note here that we do have the ability to subdivide a study into what we call seasons or regimes. Seasons is, as you might expect, you could split a study up, a longer study up into, say, spring, summer, fall, and winter. One of the seasonal combinations that I use a lot in the studies that I've done has been to split a study into a growing season and a dormant season. And the regimes is another way of splitting up a study into different periods of time that may not be recurring. So a classic example is a before and after rehab analysis. So you're going to have a before period where you've monitored that system before any rehabilitation work was done. You're going to have an after rehabilitation period where all of the work has been done, and you should see a lower impact of I&I. And you may have some period interim period in the middle that we would call a construction period or a construction regime. And SLiiCER allows us to set those periods up. Now, let's go to the next tab. So we talked about basins being primarily the area of, from which a flow monitor is measuring flows. And so this basins tab, first of all, it allows us to start looking at what are the upstream and downstream relationships. So for example, if flow monitor 2 had flow monitor 3 located upstream, I could simply tell SLiiCER that by selecting flow monitor 3 as an upstream and applying that change. It's very easy to set up a schematic for flow monitors into a project like this. Basin properties. You'll notice we have the ability to input the basin area, the sewer length, even the footprint if you want to evaluate some metric like inch miles or millimeter kilometers. That information comes from your GIS data. The other important attribute that you can leverage is the centroid latitude and longitude of your basin. This is not where your flow monitor is at, but this is the centroid coordinate of the basin associated with that flow monitor. What that allows us to do is if we have that information, we can automatically do a rainfall distribution for you. So without any other information, what SLiiCER does is it takes the rainfall gauges and it averages them and applies them to every basin in the study. But we know that rainfall does not fall that way. It has a geographic distribution to it. It'll rain more at one gauge than it does at another, and we want to take that into account. So we already have your rain gauge coordinates in Prism. So if you provide those centroid coordinates, we're able to automatically do rainfall distributions. For example, we can automatically find the closest monitor, or we can do an inverse distance or an inverse distance squared weighted distribution of the rainfall data. This used to be very laborious, but now once you provide the right information, it's automatic and you can select these. So I've had cases in the past where I didn't have time to do a detailed distribution and I had to settle for something that was a little more simplistic. But with this tool in place, with those coordinates provided, this is done automatically and I don't have to worry about the math. Now, these are really kind of setup information. So the settings you may configure or settle on once you've kind of dialed SLiiCER into your region or your preferences. The basins are project specific, but this is a one-time setup at the beginning of the study. You actually don't have to use any of this, but if you want to get the more detailed analytics and comparisons, you will need some basin information. Most of the data work after that is done on the rainfall, flow, and results tabs. So the rainfall tab is just that. It deals with nothing more than the rainfall data on the project. So the first thing that you're presented with is a hyetograph, and it has a number of things on it. I'm going to turn some of these off, but you'll notice that I have the ability to turn on and off the different rain gauges on this hyetograph. So if I want to look specifically at rain gauge 2, I can. If I need to compare that with rain gauge 1, I can. So you can turn these things on and off to your heart's content. You also have the typical capabilities like you do in most graphs in a web application. I can zoom in, zoom out, pan left, pan right, etc. Now, I mentioned that SLiiCER also automatically separates this information out into individual rainfall events. So you'll see those events here. They're already characterized by a date and a start time. And you'll see that the rainfall totals from each of the 3 gauges in this study are shown here. So you can quickly see at a glance what the totals were and what kind of variation we see between rain gauges. So that information is there. The other thing that's automatically done is we have rainfall depth, duration, frequency statistics automatically computed. I also already have my rainfall depth, duration, frequency data. In this case, it's been imported from the National Weather Service. This is NOAA Atlas 14 data that I'm using here. And then I'm able to compare that data or compare my rain gauge data for these different events in the context of this data. So I can flip through these individual events, and you can see that this particular event was almost a 1-year rain event. So let's turn some of these higher return frequencies off that aren't relevant at the moment. And you can see how close this event does or does not get to a 1-year event. So that's a very handy feature. This stuff is done automatically for you. Now, let me go to the Flow tab. This is probably, I hate to use the word busy, but this is probably the most dense information that you'll see inside SLiiCER. There's a good bit of information here, and let's walk through this. So at the very top here, I am looking at a hydrograph for basin FM01, and it just happens to be the first one in the list. And this hydrograph by default goes from the start of the study period to the end of the study period. So I'm looking here at data from January 1 through the end of April. So 4 months worth of data you're looking at. You see the data from the flow monitor, and you also see the rainfall data. So if I turn a few of these things off, you're really looking at that first conceptual graph that I showed earlier. So flow monitor data, you're seeing the rainfall data, and you're seeing the impact on the collection system from that rain event. Done just like the rainfall hyetograph. I can zoom in, I can zoom out, I can pan left, pan right to see what I need to see here. Now, the next thing that we want to look at in SLiiCER is the dry day picture. So I'm going to turn these dry days on. And for this particular basin, these days that are shaded in light green, these are the ones that are currently selected as most representative of dry days for weekdays. The ones that are shaded in light blue are the ones that are most representative of a dry day weekend. So those are the Saturdays and Sundays. And I can come down here and see this information right here. So this is my average diurnal curve in green for the weekdays. It's based on these days shown up here. And this is my curve that's set up for the weekend. Now, SLiiCER has already done these calculations for you. But the one thing that we do with SLiiCER is that we always allow the user to see the interim results and also adjust those results and recalculate it as needed. So there's always the ability to exercise your own engineering judgment when you're looking at this data. So for instance, I'm going to turn these weekday, we call them day traces, on. And let's say, for example, I want to change some of this. So I'm going to come up here to edit dry days. I'm going to toggle that on. And let's say I don't like this day right here. So I'm going to scroll down here. I'm going to select that day. You'll notice it highlighted that day right here in a darker color. And that tells me which day I'm looking at down here. Now, looks like it's February 19th. I'm going to guess that was probably President's Day, which is a holiday, and that's why it looks a little different. I'm going to just remove that. So I remove that. I can actually remove additional days. Let's take another one off here just for fun. So I removed 2 days, and I say I'm good with that. So I'm going to hit apply, and it's going to do those recalculations. You'll notice it has updated the graph on the top, the shading. It has updated the graphics here, and it has updated my statistics down here as well. So This is a nice iterative way to go through this information and yet leverage a tool like SLiiCER to do the calculations for you, but also render that data for you in a way that you can see it, and you can still have control over what those calculations are doing and understand what's taking place. Now, this dry day statistics table, I want to run through it real quick. You'll notice that it starts to show you for weekdays and weekends a lot of the different parameters associated with these dry day curves. So I've got the gross minimum flow. So that is this point right here, the bottom point on these two curves. I've got a gross average flow, I've got a gross maximum flow, and I've got a gross peaking factor. I also have estimates of what the gross wastewater production is and the gross base infiltration. And then you'll notice I switch into terms that are basically these same terms, but expressed in terms of net. Now, in this particular example, they're going to be exactly the same because I don't have an upstream basin or an upstream flow monitor. But you can see that's the terminology I was mentioning earlier, this concept of gross and net. So you're always getting those calculations automatically performed for you. The next question I hear from oftentimes from modelers is, can I get these dry day curves? These are terribly important to modelers. The answer is yes. So they're available in the results tab and you can export these curves. So that's a look at the dry day piece. On the wet weather side, I click on the storm events. And what you see is that I'm now looking at the first storm event in the list. I've got a kind of a blown up view of it here, and the top graph is highlighting the storm event that I'm currently looking at. I'm going to click on one of the larger events, this next one, and you can see I'm plotting here the actual flow on the bottom. Let me blow this graph up a little bit. Here's the actual flow compared to the dry day curves, and the difference calculated between the two is the I&I. Now there's also this pre-compensation window, so there's some additional comparisons that are being done here. And if we find a more significant difference between the actual flow and the dry day curve, we will adjust the dry day curve up or down to match the actual flow prior to the event, so that we're getting a better subtraction of the two during the event and its recovery. You've got full control of the duration of this response period. You can adjust that and calculate that or recalculate that as well. One of the things we also want to do is see, what does this event look like in the context of the other rainfall events? So this is the I&I response here on the y-axis versus the rainfall depth that caused it. And you'll see that this was the highest rainfall amount and the highest I&I amount that we saw in the system. And we also see that it is pretty consistent with the other responses we see here as well. So that information is available as well. You have the ability to edit some of these storm properties. So if I want to make some adjustments, we're going to get into this in future webinars, but you can make those adjustments. If I decide that I do not like or need one of these rainfall events, I can simply delete it. You'll notice the trash can over here. If I find another rainfall event that is not currently identified, I can actually select it on the map and create a new rainfall event. So maybe there's a rainfall that didn't meet my minimum rainfall threshold, so it's not been identified by SLiiCER, but I want to tell SLiiCER, hey, I still want to evaluate that event. I can have it create that for me. The last thing that I want to show you quickly is the results tab. And so most of your parameters that we've looked at on these previous windows can be accessed across basins here. So dry day statistics can be accessed. Storm event statistics, my dry day hydrographs can be accessed here. My basin trend lines for I&I performance, we call them Q versus I graphs. We can access the statistics on those. All of this information can be gathered, so I can just select the measure that's interesting to me or that I'm looking at the moment, I can look at it graphically. I can take those graphics and run with them. I can download the information if I need to take it elsewhere. All of that information is available to you. So that's a quick look at SLiiCER inside the product. Again, the demo I'm showing you today is on our production server live. So let's go back here to my PowerPoint here. I want to tell you about a few other details and sources of information you can go if you're interested in taking a further look. So if you go to our public website, adsenv.com, you can navigate to a SLiiCER page, or you can just type in adsenv.com/SLiiCER, and it will take you to this SLiiCER page. There's some additional information out there if you'd like to take a look. We also have some videos that are out there. There's an informational video that'll kind of walk you through SLiiCER at a high level, much like I've done today. There's also some instructional videos on our YouTube page. So these are small, 1 minute, 2 minute type videos that focus on a very specific piece of SLiiCER. So I think if you start using SLiiCER, you'll find those beneficial to help you get up to speed quickly or to remind you how to get through a certain task. So just some key points I want you to remember today about SLiiCER. SLiiCER is a suite of I&I tools that's used to extract valuable insights from flow monitor and rainfall data. So I think a lot of times we find people can feel like they're inundated or overwhelmed with data. Perhaps they don't, or they have too much data and don't feel that they have the time to go through all of that data. SLiiCER will help you go through it a lot faster. So recognize that SLiiCER is available in Prism. So Prism is our cloud-based web platform for sewer and flow monitor data, and SLiiCER is an analytics tool that is embedded within Prism. So I also want you to keep in mind that SLiiCER is designed with the wastewater professional in mind. So it takes care of the heavy lifting for the calculations, but it still leaves you in control. So SLiiCER is not a black box. It's not going to take data in and give you an answer and not let you see what's happening inside that box. So that's an important thing, I think, for engineers that both want and need to exercise their own professional judgment into the evaluation. But what we're doing is we're aiding in the calculations and we're aiding in the visualization of that information as you're exercising your professional judgment. And if you want to learn more, if you want to kick the tires around with SLiiCER yourself, please let us know in the survey at the end of this webinar, and we'll know to reach out to you and be able to set up a demo. So if you're already a customer of ours that has data in Prism, that's very easy to do. We can turn that permission on, walk you through that very quickly. If you don't have data in Prism today, we can still set up something where you can take a look at it and see how it operates inside the Prism environment. Now, so that takes care of the part 1 webinar. I want to go ahead and invite you to come back for the part 2 webinar, which will be towards the end of September. So next month, Thursday, September 26th. And I have that year wrong. It's 2024, not 2021. But yeah, join us at the end of the month, and we're going to take a closer dive into the dry weather features inside SLiiCER. And then we're going to take a break for the month of October because of WEFTech. So you can certainly come talk to us about SLiiCER at WEFTech if you're there in New Orleans. And then we're going to come back in November and talk about the wet weather piece of SLiiCER. And again, I envision some additional webinars coming along afterwards, and probably will dictate, or the subject matter of those webinars will be dictated by the feedback that I get from people like you in these first 3 webinars. And with that, Eric, I'm going to turn it over to you. I think we have a few questions that we wanted to answer.
Yeah, thanks, Kevin. Great presentation, great insight. I really wanted to thank you for that. I always learn something from these webinars, and I certainly learned a lot more about SLiiCER today, so thanks. Let's go ahead and move into the Q&A time. Wow, we have received a ton of great questions on the webinar today. Received a bunch of questions during the registration when each of you registered. Had a lot of questions that have been emailed to me, so we have a lot on our plate to start answering those questions. We'll only have time today to address just those questions that were pre-submitted. Of course, we absolutely will follow up on every question that has been submitted after the webinar. We'll start on that right away. So if you've submitted a question, it will be answered. So let's start with our first question here, Kevin. How is SLiiCER going to save me time or automate a process?
Okay, so I thought this is a very good question. So SLiiCER to me does two things. One, it lets you dig into data deeper than you could otherwise, and allows you to do it in a way that's faster than you would be able to do otherwise. So some of the time-saving features, I think I highlighted most of these, but one is the fact that if your data is already sitting in Prism, it's connected lickety-split to SLiiCER. In fact, one of the things I didn't show you was how fast it is to create a study. So that study that I was walking you through, there's a 4-step wizard to create that study. And then after you hit go to tell SLiiCER, yes, I'd like to create that study, it takes literally about, just a few seconds to actually copy the data, set up the study, and do the full initial run of calculations in the cloud. It's very fast to set up a study. Picking off rain events can be time consuming. SLiiCER's doing that for you. The dry weather characterization, SLiiCER does that as well, and automatically doing the I&I calculations. So all of those default calculations are done before you ever even step into the first graphical screen inside SLiiCER. And then you can adjust those results and update those from there. So that's the time savings with SLiiCER.
The second question, can data go into SLiiCER from flow monitors that do not belong to ADS?
Okay, so the quick answer is yes. The first thing you need to remember about SLiiCER is it operates inside of Prism. So if the data is in Prism, it actually doesn't care what type of monitor it's come from. It could be from an ADS monitor, it can be from one of our competitors' monitors. As long as the data is in Prism, it can work on it. So obviously folks with ADS monitors have data that's already in Prism, and that's an ease of use factor there. But if you have data from other sources, and sometimes we have customers that have several different types of monitoring equipment, that data can be imported into Prism and used in SLiiCER, yes.
I know we are actually a little over time right now, but this is such a great question. Let's go ahead and try to quickly address it, Kevin.
Okay.
I work in a part of the country where groundwater elevations can increase significantly from the start to the end of our rainy season. How does SLiiCER account for this?
Yeah, so there's two ways that SLiiCER has of accounting for varying base infiltration levels. One is the seasons by subdividing that study. But if you have within a single season the I&I or the base infiltration adjusting, we have a pre-compensation factor that's applied to the dry day curves before every single rainfall event. So if you've got a base infiltration level that is building across a season, that adjustment is going to be applied to those dry day curves, and it's going to move that dry day curve up or down as needed. So that's how we account for that, and it's flexible as to whether or not you want to apply it. So
Super. Thanks, Kevin. Let's make that our last question. We're over time again. Of course, we'd love to continue to receive your questions and your comments. So if you have a question or you'd like additional information on what Kevin covered today, just shoot me an email. My email address is on the screen, and we'll be happy to address any questions or provide any additional information. Again, thank you so much for joining us, and this will conclude today's webinar.
thank you.